Hello everyone, and welcome. Today we're going to add two incredibly powerful new functions to your calculus toolkit. I'm talking about exponential and logarithmic functions, and trust me, by the end of this, you'll feel like a total pro using them. So let's get started.
So here's our game plan for today. It's super simple. First, we'll figure out why we even need these new functions. Then, we'll properly meet our two superstars, e to the x and log x. After that, I'll show you two golden rules for them that are, well, they're unbelievably easy. Then, we'll unlock a kind of cheat code for solving problems that look totally impossible. And we'll finish up with a quick recap. Ready? Let's do this.
All right, section 1. So, why do we need to bother with new functions? The truth is, the answer is all around you, especially on your phone.
You've seen this happen, right? One day, a funny reel has like 10 views. The next day, your entire friend circle has seen it, and it has millions. The kind of mathematics that explains this explosive growth is completely different from what we've been using so far. The functions you already know, like your polynomials, they can't keep up with this kind of speed.
Okay, so here's the main difference. Linear growth, that's like getting maybe 10 new followers every single day. It's steady, it's predictable, you know what to expect. But exponential growth, that's what happens when a video goes viral. It's not steady at all. It starts off slow, and then bam, it just explodes. To even talk about this in math, we need a special kind of function.
So let's meet the functions that can actually handle this kind of crazy growth. I want you to think of them as two new characters in your math story, and each one has its own unique superpower.
First up, we have the exponential function, e to the x. Let's call it the unchanging hero. This is the function that perfectly models that viral, super fast growth we were talking about. It's all based on this one special number, e, which is roughly 2.718. Just think of e as the secret ingredient for maximum continuous growth. It's why this function grows faster than anything you've seen before.
And of course, every hero needs a partner. So, meet the logarithmic function, log x. We'll call this one the ultimate simplifier. And its superpower is amazing. It can take really complex problems, with lots of multiplication and powers, and it turns them into simple addition and multiplication. It basically makes tough problems easy. Now, very important point. Whenever you see log x written in your NCRT book, it always means the natural log, the one that has the base e. Please remember that.
So how are these two connected? Well, they are perfect inverses. Think of it like an undo button on your computer. If you apply the exponential function and then immediately apply the log function, you just get back to where you started. They perfectly cancel each other out. And this relationship, it's going to be so useful for us.
Okay, section 3, the two golden rules. Now that we know our functions, let's see what happens when we try to find their derivatives. And I'm telling you, you're going to love this because these are the simplest, easiest derivative rules you will ever learn.
Here it is, golden rule number 1. The derivative of e to the power of x is, well, it's just e to the power of x. It does not change at all. This is the only function in all of mathematics like this. It is its own derivative. How cool is that? That's why we call it the unchanging hero. So easy to remember.
And golden rule number 2 is just as simple. The derivative of log x is simply 1 over x. That's it. Our ultimate simplifier gives us a beautifully simple derivative. Just one small thing to keep in mind, right? The log function only works for positive numbers, so this rule is only valid when x is greater than 0.
Okay, but what if it's not just a plain x inside? What if you see something like e to the power of sine x? Don't worry, you already know how to handle this. It's just our good old friend, the chain rule. The process is exactly the same. Step 1, identify your outer function and your inner function. Step 2, differentiate the outer function using our new golden rule. And step 3, multiply the whole thing by the derivative of the inner function. It's the same chain rule, just with our new superstar functions.
Now for my favorite part, let's unlock what I like to call the ultimate differentiation cheat code. This is a technique that uses the superpower of our log function to solve problems that, honestly, they look impossible when you first see them. Take a look at this thing. Y equals sine x to the power of x, a function to the power of another function. This is like a boss-level differentiation problem. The power rule? It doesn't work because the power isn't a constant number. The exponential rule? That doesn't work either because the base isn't a constant number. All our old methods, they're useless here. So what on earth do we do?
We use our cheat code.
It's called logarithmic differentiation. This is a brilliant technique where we use our ultimate simplifier, the log function, to break the problem down before we even start differentiating. It turns these impossible-looking functions into something much simpler to deal with.
And here's the 4-step recipe to solve it. Step 1. Just take the natural log of both sides of the equation. Step 2. This is the magic step. Use the properties of logs to simplify. You see that tricky x that was in the power? The log brings it right down in front, and it just becomes a simple multiplication. So much easier. Step 3. Now you differentiate both sides with respect to x. And finally, step 4. Just do a little bit of algebra to get dy dx by itself. That's it. 4 steps to beat any boss-level problem.
And that is pretty much it. You now know the fundamentals of exponential and logarithmic functions. Let's just do a really quick final recap to make sure these new superpowers are locked in. You've done a great job.
So, what are your new calculus superpowers? First, you have e to the x, the hero of viral growth, whose derivative is just itself. Second, you have log x, the ultimate simplifier, whose derivative is 1 over x. Third, you know how to use the chain rule to connect these new rules with everything else. And finally, you have logarithmic differentiation, your secret cheat code for those really complex functions. You have seriously leveled up your calculus skills today.
I'll leave you with this thought from the great Albert Einstein. You see, all this math that looks so complex, it's really just a better, more refined way of thinking about the world all around you. From how a funny video spreads online to so many other things. So please, keep practicing, keep thinking, and you will master this in no time.